Hello everyone, myself Vlsid, Assistant Professor in Engineering College, Ahmedabad. In today's session, we discuss about junction capacitor in MOSFET. So now, first of all, I want to tell you that if you work in VLSI technology, then most transistors play a main role. Because as you know, right now we are using smartphones, smart TVs, LCD, all there LCD is there. If you look back, that we work in the analog circuit and right now we are working in the digital circuit. In terms of the digital circuit, we work on the MOSFET and transistor. Because if you work with the transistor and based on the switching of the transistor, you can work and also you can simplify the circuit very smoothly, and also it take a very less area and size as compared to other analog type of circuit. Now the question arises in our mind that why we use the junction capacitance and why we discuss about the junction capacitance. So if you discuss about the junction capacitance, in terms of the junction capacitance, we discuss about the layering capacitance which produce inside the MOSFET. See, as per the Moreno, you already know we discussed about to improve the speed of the transistor, and to improve the speed of the transistor, ultimately we have to work on a specific MOSFET, or also we have to work on the increase the number of transistors in particular area. And it is possible with help of the MOS transistor only. And for that, we have to work on the MOS transistor, and also we discuss about the drain current ID, we also discuss about the voltage variation, we also discuss about the threshold voltage, we also discuss about lambda-based coefficients and the channel length modulation. So now we go ahead in junction capacitance. Now we see what exactly the capacitance is playing a main role when we talking about a specific junction capacitance. Now junction capacitance. So there are two types of capacitance, and when we are talking about the junction, the capacitance between the N plus source and the P type of substrate is called a CSP. And similarly, the second one, the capacitance produced the N plus drain and P type of substrate CDB. So basically, we discuss about the CSP and CDB. In terms of the bodies, there we're talking about the drain and we're talking about the associated capacitance. Because when we talking about the capacitance in that particular way, we have to discuss about these three terminals. Ideally, we work on the gate, drain, and source terminal, but in the practical way, also the fourth terminal exists. It's called as a body, or it's called as a substrate bias coefficient. Now we go into the depth in the junction capacitance. So as you can see, CSP is a junction capacitance between the source and substrate, and CDB is a junction capacitance between drain and substrate that I already told you. Now, as per you can see, the diagram is represented over here. As you can see, we're talking about the N plus in terms of the source region and the N plus for the drain region. So as you can see, that because of the depletion layer, the capacitance is produced, it's called a CDB, and also it's called a CSP. So it created because of the substrate bias coefficient, and it is created because of a depletion region is produced when our MOSFET it start conducting, and before that region we have to pass from a depletion region and we have to move on a surface inversion, and after the surface inversion the circuit will start moving and it will start working because you cross a threshold voltage limit. So basically we are talking about these two capacitance when we are talking about the junction capacitance, because ultimately there are three types of junctions produced, one for the gate terminal and source and the drain. So right now we have discussed about these two type of capacitance is produced inside the circuit or inside the MOSFET. Now, both of these capacitance are due to the depletion region charge surrounding the respective source or drain diffusion region in substrate. So as I already told you, the reason is very clear. Because of the depletion region charge, it produces a specific type of the content, and it produces a depletion region and it produces a diffusion region, and because of that region you can see the variation in capacitance effect. Now, both of these junctions are reverse bias under the normal operating condition. So basically when you are in normal mode, then ultimately we have to work in a specific region based condition. So the amount of junction capacitance is the function of applied thermal voltage. So what exactly the effect of capacitance? It is produced because of the applied thermal voltages that you have. So basically it's totally related with the applied terminal voltages that you have specifically applied for the amount or for specific region. So the junction capacitance are the voltage dependence is defined as you can see the equation is Cj is equal to mode of dqj divided by dV. So when we are talking about the dqj, the dq is the change in the depletion region charge, and similarly the dV is the change in the applied voltage charge. So basically when we discuss about depletion region charge, then we are talking about the dqj, and when we are talking about the change in the applied voltage, we discuss about the dV. So ultimately the voltage play a main role, and based on the voltage variation you can see the variation in the depletion region. So ultimately, these are work specifically for the region in terms of Cj, in terms of dqj divided by dV. So here you can see the 3D way of specifically MOSFET, and we discuss about the 3D way or graphical representation of the MOSFET, and you can see the labeling over here in terms of the 1, 2, 3, 4, 5, and Cj. Y terminal is there, source and drain terminal is there, and as you can see the channel is also there. So now these numbers are represent the different types of capacitors is produced inside the MOSFET when your MOSFET is start conducting and when it start moving. So now we go into the tab and we can see the which type of capacitors are produced near the particular this 5 area, as you can see as per this particular diagram. So from the first region you can see the area W dot xj in terms of the n plus divided by p. For y dot xj similarly n plus plus p plus. For wxj similarly you can see n plus n p plus. For yxj you can see similarly it's n plus p plus, and wxj for the n plus n p. So ultimately we discuss about the junction depth, width, and the channel length. And based on these three parameters, we have to see the different types of movement and variations in the MOSFET side. And based on that, we work on the different types of situation and scenario. So I hope that you are getting the idea about what exactly the MOSFET is and how the MOSFET is play a main role when we discuss about the capacitance related variation and area. So I hope that you are getting the idea about the junction capacitance, and also you are getting the idea that what exactly the junction capacitance is. So still if you face any doubt, or still if you have any doubt related to the capacitance and related to the MOSFET related capacitance, then you can please tell me and I will definitely try to solve. And I will tell you some critical question which is related to the capacitance. When you change the capacitance effect, then still it produce a major change in the MOSFET area. And even when designing any PCB, when we design the track, the capacitance play a main role, and it will also affect your hardware properties too. So here the question is that what exactly the use of capacitance in the PCB designing, and also what exactly the use of capacitance when we work on a charging based circuit. So capacitance have many advantages when we discuss with the real-time applications, but here I have two questions and I will give you the answer is that when we work on the capacitance on specific area oriented tasks, then capacitor is work as a filter, and also it is generally work to smooth your charge properties. And for the PCB designing, it play a main role. So make sure that it play a main role to debugging the circuit, and also it play a main role to simplify the circuit. Ultimately, when we are talking about the capacitance, there are two types of capacitance in the Vlsid technology: the oxidated capacitance and also the parasitic capacitance near the junction. So there are the two types of capacitance which play a main role in Vlsid technology, and also to make sure that when we work in the fabrication or when we work on the Vlsid technology, then ultimately capacitance play a main role when we are working on the charging and discharging based circuit. And also it play a main role when we discuss on specific area oriented circuit, right? So capacitance is play a main role, and also we discuss about the scaling factor, that which type of scaling factor is there in Vlsid technology, and how we can work in the scaling factor to reduce the area optimization too. So I hope that you are getting the idea about Vlsid technology and about the junction capacitance, that what exactly the junction capacitance is,
and how you can simplify it. So make sure that when we discuss about the capacitance, we have to deal with the two parameters only. It's for the substrate and for the drain terminal. And when we use substrate and when we are talking about the source, substrate and drain terminal, the source and drain both terminals are connected to the substrate bias coefficient. So ultimately we are dealing with a specific content, and ultimately we are working on a specific substrate bias coefficient. So basically in this particular parameter or in this particular calculation, we work only on the capacitance related task. Okay, so I hope that you are getting the idea about which type of capacitance is and how it will affect the MOSFET characteristics. Make sure that these capacitance are playing a main role to increase the performance of any digital circuit or any integrated circuit. So I hope that you are getting the idea about the junction capacitance.